Okay. Well, thanks again for everyone turning up to the second Eastern session. Just want to greatly thank my team members, Arthur, Paul, and John, for all the work that they've put in. And also, we do acknowledge a bunch of other people who, over the last 11 years of this project, have put in a considerable effort as well. And we also do want to acknowledge the financial support we've also had from Tadwig, Atlas of Living Australia, the MCZ, VertNet and Curator also, because we did get support to travel to a few face-to-face meetings, which we found to be extremely important. Right, a little bit of background. The Biodiversity Data Quality, or we're just nicknaming it BDQ, is a proposed standard for handling or at least evaluating the quality of biodiversity data. We've been running for over 11 years since this project started. And about May last year, we did submit BDQ for expert review to a great team, which you'll mention more about in a quick video clip. And we received that review on the last day of last year. And we've been working on it pretty solidly ever since to respond to that excellent review. Excuse me. I won't say too much more about it because I think the little video clip that we've generated thanks to Notebooks LM will go into it a fair bit. But needless to say, we did a fair bit of work updating the documentation to respond to the comments by that review committee. The standard does contain I haven't really added up the number of pages, but it's a considerable volume because it contains really the foundational framework for evaluating data quality. We've also included documentation for users and implementers and a quick reference guide similar to that related to Darwin Core. But we've also included quite a bit of contextual information in a supplement document and a very comprehensive tutorial. We've also included test validation data, and Rakaya has already implemented an application based on BDQ called BDQ Email, which I guess many of you know about. And we look forward to the establishment in the near future, hopefully, of a maintenance group that will take the standard on and evolve it. The landing page is at the moment still in GitHub, although we're in the process of attempting to transfer that across to Tadwig before the public review. So a little bit more about BDQ. This is just a Notebook LM graphic, which at least it covers it. It looks like one very complex machine, which BDQ certainly is. But the foundation of it is, or at least the components of it are really pretty simple. And while we have based BDQ on Darwin Core, it is functionally independent of Darwin Core. Sitting at the bottom, you've got a bunch of vocabularies. I think we're up to about 6 now, but Paul might want to correct me on that at some stage. I haven't just counted it up in the last few days because we've actually split one of them up recently. And an ontology, which is comprehensive. And you can really say, while we've focused on the tests, there are 4 different types. There's validation type tests, issue tests, which provide a warning, which would require human intervention to evaluate. Measure tests, which either look at some sort of a quantitative metric and also can operate not only on single records, but multiple records, and amendment tests, which at least provide some, or they're paired to an equivalent validation test to provide potential for updating the data and improving the quality of that data. The output is formally covered by data quality reports, which will give you a very standardized output from BDQ. And BDQ is quite independent of implementation type, although Paul has implemented it. All the tests in Java, which you might say something about a little later, it's quite independent of any implementation, and it's quite independent of a number of other factors, which I won't go into right at this stage of the game. So let me just go into a Notebook LM summary of where we're at regarding the review.
Welcome to this explainer detailing Task Group 2's work on the proposed Biodiversity Data Quality Standard, or BDQ for short. If you're part of the Biodiversity Information Standards community, you already know just how vital this framework is. So today, we're zooming in specifically on the review and responses phase. Over the next few minutes, we'll see exactly how expert feedback shaped and truly leveled up the final standard, bringing us right to the starting line for public review. Here is our roadmap for today. We'll be walking through the review team's feedback, our overall baseline assessment, how we completely updated the documentation, clarified core concepts, refined the test suite, and finally, the steps we're taking to prep for public review. Right, let's start with the folks who made all of this possible. We absolutely have to give a huge thank you to our review team, Melissa Liu, Ruqaiya Jahadeen, Sophie Pamerlon, Stephen Formal, and Dag Enderson. These experts didn't just casually skim the text. They actively took on specific user roles, from end users all the way to test implementers. And you know, this role-based approach was a total game changer. It gave us that critical, real-world feedback we desperately needed to ensure the standard actually works for everyone. So, what was the baseline consensus? Let's take a look. The ultimate goal of the BDQ framework is pretty straightforward in theory, but incredibly complex in practice. We're taking raw, highly variable occurrence data and running it through a structured gauntlet of tests to output refined, usable data. Well, the best news from the review was that the foundational consensus was incredibly positive. Reviewers unanimously agreed that the BDQ standard is architecturally and technically solid. It builds beautifully on Darwin Core and seamlessly fills a massive gap in our community's infrastructure. But there was a catch. The reviewers noted that while the standard is technically ready, the main barrier is presentation. Basically, the engine runs perfectly, but the user manual needed a major overhaul. Our mission shifted entirely from engineering to communication, making sure that technical readiness translates directly into user readiness. And that leads us straight into our biggest challenge, documentation and navigation. The reviewers were very clear. The documentation was exhaustive, but jumping into it felt a bit like hitting a brick wall. So, we completely re-engineered the BDQ landing page to act as a guide to the guides. Instead of wading through hundreds of pages, a master index now acts like a traffic controller. For example, if you are a developer, you're routed straight to the implementation steps, completely bypassing the heavy introductory theory that's meant for curators. To make things even easier, especially for international teams and different technical backgrounds, we built out highly requested visual roadmaps and concrete tutorials. Because really, who wants to read a giant theory manual before seeing how things actually work? Now, with clear flowcharts and step-by-step guides, you can instantly grasp the mechanics of the tests and apply them to your own specific use cases right away. Moving on to our next key area, clarifying core concepts to remove any lingering ambiguity. A vital piece of feedback was that we needed to front-load the why of BDQ. So we added a crystal-clear value proposition right at the very beginning. We also completely rewrote the sections on quality assurance and quality control. Those two concepts are now highly distinct. We want to make sure everyone understands the difference between QA, which is filtering data for a specific immediate use, and QC, which is identifying data that inherently needs to be fixed right at the source. We also had to do a bit of jargon busting. A major change was renaming our core term assertion to response. This wasn't just semantics. It was a deliberate move to disambiguate it from similar Darwin Core terms that were causing friction. Crucially, this new name cleanly separates the metadata about a test, the response status, from the actual data output itself, the response result. It's so much clearer now for both human readers and automated implementation tools. Okay, let's look at the functional refinements we made to the test suite and the quick reference guide. For the quick reference guide, we made things incredibly fast. We slashed the long introductory preamble so you can get straight to the content. And we added dynamic filters. Now you can instantly filter by use case and test type or browse alphabetically in seconds. Let's keep moving. As for the tests themselves, the reviewers caught some seemingly illogical mappings, like why would a taxonomic name check show up under spatiotemporal patterns? Good question, right? To fix this, we formally added fitness requirements directly into the ontology. This spells out the dependencies clearly, basically explaining that a spatial pattern test is virtually useless if we don't have accurate taxonomic data attached to it first. We also tackled the reality of global data variability, especially regarding dates. Reviewers asked how we handle non-Latin alphabets or alternative formatting. Well, we updated the implementer's guide to ensure that unambiguous strings, like a translated month name or Roman numerals from 1 to 12, are handled smoothly. Instead of failing a test, they're correctly translated into standard integers, and the system simply returns an amended status. Let's move to our final section and see how all of this builds our readiness for the wider community. We did a meticulous sweep of every single document. We untangled and strictly separated normative requirements, which are the rigid rules you absolutely must follow, from the non-normative, informational examples. We also consolidated the ontology guide, so all the definitions live in one handy place, and we updated our glossaries. The result is a genuinely polished, cohesive standard. You can check out all the fully updated documentation right now at the GitHub link provided. Just keep in mind that all these resources are going to be officially migrated over to the TDGW site right before the public review phase kicks off. Thanks to this expert review, BDQ is no longer just a great technical concept behind the scenes. It's accessible, logical, and ready for action. The tools are in your hands now. How will you use these standardized tests to elevate the quality and reliability of your own biodiversity data? Thank you so much for joining us, and we absolutely can't wait to see your participation in the upcoming public review. Welcome to this
Right. Oh, there was one other little bit that I thought would be appropriate to show you was just one of the tests. So what you're really seeing is the description of a test for the validation of a scientific name. So you can see all the infrastructure that's sort of sitting behind this one test. For example, the label gives you an idea, and it's in a standardized format that it's a validation type test. The focus of the test is scientific name, and the action associated with it is that scientific name found in a source authority. So it has an English description here, which is sort of sitting slightly in the wrong place. Is there a match of the contents of Darwin Core scientific name with the source authority? So you can already start to see some of the vocabulary terms coming into this, not only Darwin Core, but obviously BDQ as well. The expected response here is more a explicit definition of how this test operates. So for an implementer, this would be the bit that you really need to look at, and that is meant to be unambiguous. The data quality dimension is this is a conformance type test. So you can see that the scientific name associated with the source authority and so on and so forth. I won't go through them all, but at least you get a bit of an idea on some of the, dare I say it, core aspects of BDQ, but there's a heck of a lot behind the scenes, which I'm sure all of you are getting a bit of an idea about. So I'm just going to open it up now for questions.
Oh, here's a question. Do you know if BDQ will be incorporated to improve the GBIF data validator? Are there any plans already on this? Thank you, Ricardo.
Paul or John? I don't know what the state of that is.
I don't know of any such plan. I don't know what GBIF has pending when this comes out at all.
Yeah, current state, I'm not sure. They have certainly talked with us in the past about incorporating this into handling data, but I don't know where they are currently in their thinking or their work plan.
Yeah, the last I basically heard from Tim Robertson was that he certainly was wanting to use the infrastructure of BDQ, but like I think anyone who would implement the BDQ standard, there's sort of plus and minuses regarding appropriate tests, for which I hadn't said is dependent upon the application or use case in the case of the terminology of BDQ. So in other words, all of the infrastructure that sits behind BDQ, Tim was certainly wanting to utilize, but the plus and minuses on some of the tests, the appropriateness of the test might have been another issue. But Paul might want to say something about that.
I think, and I'm speculating here, part of their concerns is at the heart of the framework for fitness for use is data are only fit for use under some particular defined use. So in the framework, those are use cases. Not quite the same as software engineering use cases, but sort of similar. Any aggregator is serving multiple communities and multiple uses. So in order to integrate the thinking of the BDQ framework for fitness for use and the tests, they have to think about how to integrate that concept of use cases. It's not quite as simple as implement all the tests and present all the results to all of the users. Implement all of the tests may be a good thing, but then you're dealing with, okay, what set of test responses apply in a particular situation for some user. So there's a little bit of complexity added there by the formality. John.
What you say is true. However, given what GBIF does already with the production of their flags that they append to the outputs when you do queries, the data quality assessment could be in the hands of the user as opposed to in the hands of GBIF, which is, to me, appropriate. So GBIF could provide their flags as test results, standard based on BDQ now, and then users could use this framework to apply data quality assessments on those downloads. So It seems to me a natural that if GBIF wants to be serious about their flagging in terms of making them standard outputs, that they could adapt what they do already in pipelines to make flags into BDQ test outputs.
Thanks, Paul and John. That raised another issue, and that was that when we first had a look at reviewing the current tests, this is going back probably over 10 years at least, all of the tests that were currently being run by data aggregators such as ALA, GBIF, iDigBio, etc., were all flagging problems with the data. And as you probably saw from the test example, we're flagging the quality of the data. So we had to turn the failures around into estimates of data quality. So that was the one immediate difference that you would notice.
There's a couple of questions in the chat. One from Beth is asking, is this applied at a specific occurrence event level or at a data package level, or can this do both? And then quite related to that, from Ricardo, asking, will there be changes coming from the implementation of DWC data package? So really central to the framework is the concept of a single record, which is not necessarily a flat row in flat Darwin Core or any flat data, and a multi-record, a set of multiple records. And then the vast majority of our tests that actually do something interesting operate on the level of an individual single record. So for a single record which contains Darwin Core day as a term, does that value of that term in that record conform to the rule that it should be an integer? And does it conform to the integer that it should, to the rule that it should be an integer that's one of the days of the month? So tests are separate, distinct, very, very granular like that, each one trying to ask a single question. But then the tests are assembled in essentially a suite of tests for a particular use. And the expectation is the set of tests are run on a multi-record, one or more data records. And then that produces a set of results. There are a set of tests that can operate on those results and say how consistent your data set is with the expectations, or let's set up a filtering rule that filters down your data to just the records that conform to the expectations for that use case. Inherent in the design is there's an API, and a test really defines an API that says outside of that API, we're not taking any responsibility concern. It's your concern how you transport your data, how you manage your data outside of the tests, but you present the data to a particular test with a particular defined set of inputs. So a test for Darwin Core Day has an input for the Darwin Core Day term, or something that you have in your moving data around that you mapped onto that term. Then internal to the test is rules about the analysis of how you evaluate the value of GWC day. So a rule, is this an integer? Is what's described very specifically in the expected response of a test definition. That also frames what's coming out of the API. Coming out of the API is a very structured, very stylized response, which contains a status, which tells you whether the test could actually do what it's supposed to or not. And the actual result of the test, and really, really important, a human readable comment that describes why the test came to the result it did for that particular data input. So yes, it can apply to a single specific occurrence. We're not restricted to occurrence records by the framework. We're really focused on occurrence records in the initial set of tests that we defined. But we could easily frame tests that would operate on media records in AC, and would do quality control on AC data. Because we have the generalization of a single record might be flat or it might be structured, we can readily accommodate Darwin Core data package and say, there is this thing that is an occurrence plus related stuff in some complex set of relationships in Darwin Core data package. And we want to take that one complex set of things and use it as input to tests. But the handling of that and how you map basically the fields you have in the Darwin Core data package to the particular inputs of the test is really up to the responsibility of the implementation framework. So that's where we said we're very independent frameworks for implementing the tests. This could be, and we give some examples, some actually lightweight. You can run some of the tests as SQL queries inside your database. Or you could have these as actors that are working in a data processing pipeline. Or you can have a tool that reads in Darwin Core archives with star schema, and you grab the set of terms from a record off of an occurrence in that occurrence core, and you process it and you present results. Or you've got something more complex in Darwin Core data package. All of that, how do you marshal, how do you serialize, deserialize? Are you parallelizing your processing? All of that is left up to implementations of frameworks that run the tasks. So no change needed because of Darwin Core data package. And I think that's answered both Beth and Ricardo's questions. John.
So that was a whole bunch of stuff. Can I take the opportunity to take out a couple of golden nuggets from all that? Okay, so from the Beth question, the answer is yes, yes, and yes. But the important thing to understand is that what the tests act on are input elements. So wherever those might come from, whether it be an occurrence record or an event record or a survey record or whatever, the tests apply to the specific elements that might be contained in those data. And then in terms of BDQ, the issue that is slightly different is the concept of what a record is for those tests that are measures at a multi-record level. So take a simple example. Suppose your data set has multiple identifications per specimen, and you're doing some kind of a test on identifications, or some kind of a validation test on identification. So every record might have, every occurrence or material record might have multiple identifications in it. And what you're measuring might be the set of all identifications rather than the set of all specimens. So you need to define what your inputs are going to be, at what level. Do you only use the accepted identification, or do you want to make some kind of measure per specimen about how good a whole set of identifications are, etc. So you, as the consumer, would put together the view, basically, out of the data package of what it is you want to measure quality on, or what tests you want to run. But the framework, the standard, everything that has been built can work in all of those scenarios and more.
Thanks, John and Paul. Is there any other key component that we've left out? Test validation data. BDQ comes with a test data set that you can validate against. In other words, a series of fixed inputs and expected responses. I've got, I think it's about 1,100 bits of input into BDQ.
Tadwig has a raised hand.
Is it possible for you guys to run through a quick example of how it would work, like for something simple, like latitude or something, you know, put a range of -90 to 90, and then you get a value of 100 or something like that? Is that possible to do in this context, or is it too? I should run through an example.
John, latitude was mentioned.
Totally, examples don't totally use just an idea, but
Oh, that's fine.
Trying to understand like the story around the actual test and what that might look like. So there is a test that validates whether a latitude is within range. It's a simple test. And it says basically inside the test is the value there? Is it not empty? Would be one test. And another test would be, is the value a valid floating point number between -90 and +90? There's more than one test about decimal latitude. And so how you build that into a broader framework depends on what you're testing for, whether it's a data quality thing, for being able to use data for species distribution modeling, or things like that, is the bigger picture in which you find that test. The test itself is fairly straightforward. Now, how it's implemented is a separate question entirely. So we've created an implementation that will take as input a decimal latitude, and the implementation is in Java, and it will produce the outputs depending on what you gave it. And the outputs are the response structure that you find in the definition of every test. So Paul's put in a link there that talks about that particular test, one of those particular tests that I just mentioned. So if you look at that link, you'll see a definition of, in this case, a measurement test, which is across multiple records that have that are testing for the compliance of a decimal latitude to be not empty. So the results of this test would basically tell you how many from the input records have a decimal latitude that is not empty. And not empty is a very formal definition that you can find in the framework as well. So that's an example. Does that help?
It does.
Okay.
Isn't actually one I was looking for. You grabbed the wrong link.
Yeah, there's a decimal latitude in range, as well as the decimal latitude not empty, but we also have a bunch of tests too which relate to coordinates, which is coordinate center of country, coordinates from verbatim, coordinates not zero, coordinates transpose, coordinates country code consistent, coordinate state province consistent, coordinates terrestrial marine consistent. Hopefully
so
some
this
of
is
those
interesting. Yeah, that whole list that you just brought up, Lee, it would be a useful thing, and a quick reference guide would be the way to say what tests are there that have latitude or decimal latitude, whichever term you're really looking at, as an input, or alternatively as an output, like which ones can amend them or suggest amendments to them, more strictly speaking. So Paul's put in a link to another test, and this one is for a valid decimal longitude in being in range, so minus 180 to positive 180.
I can imagine for a quick reference guide. I've got some data. I need to test the latitude and longitudes.
Yeah,
Which of
what's
these
out
tests
there.
have? Yeah, and then just grab those and just pull them in.
Yeah. Looks like there were a couple other comments interspersed here in the meantime.
Elspeth has a question or a note. MIDS. So interesting to see the connections between BDQ and MIDS, particularly for empty values, i.e. completeness measurements. Yes, exactly. It should be really straightforward to frame a use case for a particular MIDS level and compose a set of tests for emptiness, not emptiness, you know, for the things that are expected in that MIDS level. We played with that a little bit a while ago, but we haven't actually formalized such a use case. One should be real straightforward.
It'd be straightforward based on the tests that have already been included in the proposals, but MIDS will have others as well for terms that are, if you just wanted to check for not empty, that weren't in the core 110 that we produced based on use cases that we were interested in covering. But yeah.
Go ahead, Elspeth.
Yeah, I'm just what I'm thinking, I mean, looking to the future is maybe kind of formalizing some of the connections between these two. And it's nice that Ben's here as well. So the idea that, you know, we can provide links from the MIDS through to the BDQ so that people can actually do more than just look at completeness, but they can then look at the quality as well.
Yeah,
I think would be nice.
And they could also steal the Java code to do it.
Correct. Borrow.
Where's the Java code exactly? You should think.
hang on.
Do you want to put the link in?
Okay.
One thing I'll mention that I think it might be that might be useful is that while we've got 110 tests, we certainly had up considerable interchange of tests over those 11 years. And what the 110, what we're calling the foundational ones, but there's a bunch of others which you'll find in GitHub under different tags, such as supplemental, that we thought, well, we had a whole series of criteria for the tests, and obviously quite a lot of tests didn't fit all those criteria. But so we had supplemental tests. We also had a category called do not implement, which are really nice to look at, and I think they're covered in the supplementary document, that they might appear to be bleeding obvious tests to have, but when you come down to actually implement them, they're impossible to implement currently. But we've tagged them in GitHub, and there's a list of them. I think they're covered actually in the supplement document as well. And I think there was another category, was there not? I'm just trying to think what it was.
There's a category of immature.
Oh, immature, incomplete. That's right.
Yeah, let me link to those.
Yeah, that may be helpful for people to look at, because there's quite an education in what we did not include as well as what we did include, put it that way.
I want to make sure that Beth's other comment here was addressed. She said, thanks. I guess the implementation will be where a report can be designed to provide an output that can say what % of records meet specific data quality tests. They would meet specific data quality criteria using a set of tests. Yeah, but yes, exactly. While we were talking about MIDS and this idea that sort of a generic thing that happens there is the question of whether data have been provided for a particular field. So would the framework allow for there to be sort of a meta test? So rather than defining 168 different not empty tests for Darwin Core terms, could there be a test that says, give me the name of the Darwin Core term, and I'll tell you whether it's empty or not? Or does that not fit the framework?
So that is, a feasible behind the scenes implementation of doing things, but it doesn't fit really well with the test API of I've got particular information element inputs and I'm giving you a response. What is easy to frame is a test which has 6 different Darwin Core information elements as its input. And then says, for this validation to be compliant, every one of these terms must contain a value. So you could actually frame a single test that matches, say, MIDS level 1. That's real straightforward to do.
Right. Right. You wouldn't need the generic one. You could construct the specifically targeted one based on a use case. Mm-hmm.
Yeah.
And that's kind of what we'd hoped could be built, were such use cases of aggregates of tests.
Okay.
Because one cannot anticipate, one would not even want to try to anticipate all possible use cases for data quality, because that's in the eye of the beholder.
So then we would need to figure out what constitutes a value and what doesn't. Like an empty string, an asterisk, the set of values.
No, that's all very well defined. Not empty is a very formal definition.
Right. But then beyond that, beyond just not empty, just, asterisk or NA, or what constitutes a valid value for a MIDS to satisfy the MIDS criteria in a way, right?
Yeah,
Yep.
that's a different thing.
But I could build that into the test, basically. Saying these values are not.
That's right.
You would make,
if,
an implementation that translates them. Mhm.
if you need to have a value be both empty and conform to some other criterion or some other set of criteria, you could compose one test that does all of that. We generally advocate against doing that.
Yeah, I can see why.
under the principle of keep each test as atomic as possible,
Yeah.
doing a single simple thing.
Mhm. And act on the responses.
Yeah. So if you're doing quality control and you're trying to improve your data, and some test comes back basically saying, there is some problem with your record, that's a lot harder to deal with than a test which comes back and says, well, this record has no value in this required field, and this other value has a value in that field that doesn't conform with the expected controlled vocabulary. So the more that you separate out the concerns in the definition of an individual test, the more helpful the test results will be for figuring out how you're going to approach the big data cleanup projects involved in quality control.
Right. Now that we have decided this is not a valid value for MIDS, try again.
And I think that's sort of a key point we make in the tutorial, which goes through how do I describe a new use case? How do I describe some new tests to go into that use case? Is the process is very iterative. That's what we've learned over the last decade. We frame something, we say, this should work. And we frame a definition for it, and we take it up against real data and said, no, it doesn't actually work. We got to frame this differently. So multiple iterations and coming to, okay, what is it we actually really want to do here?
Yes, to make it even more explicit, Paul's examples in the tutorial show you that if you're attempting to add a new test to BDQ, for example, that's definitely going to be an iterative process because it interacts with the use case, as we've noted a couple of times. In other words, well, exactly what context are you going to use this test in? So what you end up doing is defining probably an initial idea of what a test might do in those circumstances. You'll change the circumstances, then go back and refine the test, and probably then redefine the use case.
Yeah, so part of the iterations that we went through were we would, discuss the definitions for a test, settle on something we thought was sensible, then I would go off and write an implementation, and Lee would go off and compile a set of records to validate that an implementation does what he expects it to do. We'd run the test implementation on those and we'd say, wait a minute, we're not in agreement here. We got to go back to, okay, is it a problem with the definition of the test? Is it a problem in the implementation? Is it a problem in how we're thinking about the test results? And usually it came to, we really aren't framing that definition in the way we should be. And we're making different assumptions. So that, that iterative process involving define the test, implement it, and then validate it if it does the implementation actually do what someone who didn't implement the test expects it to do. John?
I don't see that we've had any other questions yet, but I wonder if we can muse about what the timeline might look like from here forward. We have a couple of steps. One is finish up all the responses to the reviewers' comments. And is that it for getting it to public review, or is there more beyond that? Then public review is a well-known process. It provides for a minimum 30 days. We can set that to be longer if we think that's necessary. But the process itself can go on for an unknown amount of time, depending on what happens with the community. Then when that's done, and there seems to be consensus about what's out there, after adjusting for those commentaries, then a proposal is put together to the executive committee to say, or to assess whether or not we followed process correctly in the creation of this new standard. And they have 30 days to evaluate that. So there's a minimum of 60 days involved with review. Plus, there's all the stuff in the middle that's a little bit less predictable. Plus, there's this getting to the point of public review. That's those are the knowns and semi-knowns about the timeline. So where does that put us? What's the soonest that we could possibly have a BDQ standard? I think reasonably it would be 3 or 4 months, if that's if everything went really quite smoothly. Does that seem reasonable? Am I assessing that correctly?
Yeah, I'd agree, John. We're very close to getting a response back to DAG as the review manager. And while that is in the process, we will be attempting to transfer the documentation across to the Tadwig site.
What we do want to do is 2 things before going to public review. One is get the human readable documentation and the other artifacts up under bdq.tadwig.org, including a nice, clean, pretty filterable version of the quick reference guide to the tasks. Second thing we want to do is we want to demonstrate that we can get the pieces of things that are needed for the formal description of things in rs.tadwig.org. We really want to do this because we have an ontology. And that's something that is breaking new ground for the current set of Tadwig standards and the current architecture for delivery of information about the standards. So for the public review process, for those people who are really, really technically inclined, we want to be able to demonstrate that, yes, this works and there aren't going to be any big hiccups when we move from draft to actual approved deployment.
We're pretty close to time, so I don't know if there's any other questions.
Yes, anybody? Thanks, guys. That's very informative. Good.
Thank you, Ben. Thank you, everyone.
The only timeline mode is trying to figure out, I think we'd rather not have mids and BDQ public review at the same time, but if that's the way it goes, that's the way it goes. You know what I mean? Just, I mean, you'd rather keep them, a little bit separate, but not to hold anybody up in it either, right? You know what I mean? Just as an important note. Right, Elspeth, I think so whoever's ready first. It's a race to get to public review. So, anyways, thanks guys. I'm gonna stop the recording here.